Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called The Jolly Caucus Race by Katie Splendor. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have Caucus cages, where digits inside a Caucus cage do not repeat and sum to the number in the upper left corner of the cage. So as an example, we could have something like, say, 2, 6, and that's not right. That's not going to work. 4, 6, and 8 here. That adds up to 18 because we have 3 digits here, all adding up to 18. 4 plus 6 plus 8 adds up to 18, which is the number in the top right corner of the cage. Or top left corner of the cage. Apologies. And that's how Caucus cages work, otherwise known as killer cages, but in this case, they are Caucus cages. And we have dodo dots, where digits separated by a black dodo dot have a value ratio of 2 to 1, and there is no negative constraint. So, for example, if this were a 4 here, this would have to be 2 or 8 to maintain the 1 to 2 ratio that's between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, this digit is in a 1 to 2 ratio with 2 other unique digits. The only possible digits that are in a 1 to 2 ratio with 2 other unique digits are 2, which is in a 1 to 2 ratio with 1 and 4, and 4, which is in a 1 to 2 ratio with 2 and 8. However, if we have 2 here, this is going to be at most 2 and 4 here for these 2 digits, which only adds up to 6, and that would require a single digit to add up to 18 minus 6, which is 12, which obviously a single digit cannot work. So this cannot be 2 here. This has to be 4. Obviously, this can't be 4 and 2 here as a 1 to 2 ratio because of the same problem. So we have 4 and 8 here, and that's 12. 18 minus 12 is 6. 6 is in a 1 to 2 ratio with 3 only, and 4 is in a 1 to 2 ratio with 2 and 8. Well, this is also a 1 to 2 ratio here, and it can't have 3, 4, 6, or 8, so this must be a 1, 2 pair, which leaves the remaining digits in column 5 as 5, 7, 9. Well, to add up to 10 here, it cannot have a 9 here because 9 would not be 9 plus 1 and 2 adds up to a minimum of 12. Also, in each of the corners, we have 3 digits which add up to 23, 3 unique digits. The only 3 unique digits which ever add up to 23 in normal Sudoku are 6, 8, and 9. So we have a guaranteed 6, 8, 9 here, a 6, 8, 9 here, a 6, 8, 9 here, and a 6, 8, 9 here. That means in those boxes, 6, 8, and 9 cannot appear anywhere else. Well, then, in column 3, column 7, row 3, and row 7, where are the 6, 8s, and 9s? They cannot be here, they cannot be here, so they have to all be here. Same with this. They can't be here, they can't be here, so they must be here. They can't be here, they can't be here, so they must be here. So 6, 8, and 9 in the upper central box, the lower central box, the left central box, and the right central box all have to be in either row 3, row 7, column 3, or column 7, depending on which box it is. So this has to be 6, 8, or 9. It cannot be 5 or 7, so that's 9. This is guaranteed to be 6, 8, or 9. This is 6, 8, or 9. 6, 8, or 9, 6, and 8, 6, and 8. 9 can never be next to a black crop key dot, because if you have 9, it's going to be 4.5. If you double 9, it's 18, neither of which are digits. So this is 6, 8, which has to be with 3, 4 as a 1, 2 pair. We have 6, 8, 9 here. That means this can't be 9 here. This can't be 9 again because 9 can't be next to a black crop key dot. This can't be 9 either. So 6 and 8 is next to 3 and 4. This is guaranteed a 9 here, which means this cannot be 9 there. We have a guaranteed 9 here, which means this can't be 9 there. Remaining digits of column 7 and row 3. We have a 3, 4 pair in each of those columns and rows, and a 6, 8, 9 triplet in the rest of those rows. So it's 1, 2, 5, 7 remaining. 1, 2, 5, 7, 1, 2, 5, 7, and 1, 2, 5, 7 here. In this upper right-hand box, we have a 1, 2, 5, 7 quadruplet, which eliminates 1, 2, 5, 7 in the rest of the box. So this is 3 or 4. These also have to be 1, 2, 5, 7 because of a 3, 4 pair in the 6, 8, 9 triplet in the box. Okay, remaining digits in this upper central box. We have 3, 4, 5, and 7. 7 can't be either of these spots because obviously if there's a 7 here, it has to be with 1 and 2 to add up to 10. So this has to be either 1, 4, 5 or 2, 3, 5 here. So we're guaranteed a 5 in one of these two cells, which eliminates. Also, we have a 3, 4, 5 triplet actually in row 2, which eliminates 3, 4, 5 in the rest of the row. So no 5 there, no 5 there. 7 then in this upper central box has to be one of these two digits, which eliminates 7 in the rest of the row. So this can't be 7, this can't be 7. Can this actually be 7 here? Where's the 7 in row 2? If we try to have a 7 there, 7 plus at minimum 3 and 6 does add up to 16, so that could be 7. Okay. How about adding up to 10 here? Six eliminates 6 from here and here. 2, 8 as a pair eliminates 2, 8 from the rest of row 6. So in row 6, the remaining digits have to be 1, 3, 5, 7 because of the 2, 8 pair and the 6, 9 pair in the row. The rest of this lower central box have to be 1 through 4. This is either 1, 2, and 7 adding up to 10, or 1, 4, 5, or 2, 3, 5 adding up to 10. What about this cage adding up to 10? These two digits have to be the same. They're in a 1-2 ratio with the same digit. So we'll mark that as blue. These two digits must be the same. So they're going to be blue and blue. That makes this not the non-blue 3, 4. This is red and red, which means this has to be the non-red 3, 4. So this 3, 4 is going to be in a 1-2 ratio with this 6, 8. That makes this the blue 6, 8 there. This is 3, 4, which makes that the red 3, 4. That means it's the red 6, 8 to be in a 1-2 ratio with it. Well, this is the blue 6, 8. This is the red 6, 8. That they both see this cell, so this cannot be blue or red 6, 8. Same with this blue 6, 8 and red 6, 8 there. That means this can't be 6, 8 here either. So this is 9 and this is 9. No 9 here, no 9 here. This is the red 6, 8. This must be the blue 6-8, which means this can't be blue 6-8. It's red 6-8 here. So red 6-8 is here. Blue 6-8 can't be here, so this must be blue 6-8 here, which means this can't be 6 or 8. It's 9 there. Red 6-9 can't be here, so where's 9 in this upper left-hand box? It must be there. This is red 6-8. Blue 6-8 is here, red 6-8 is here. One of these is red 6-8, one of these is blue 6-8. Remaining digits of the central box are 1, 3, 5, and no, not 1, 3, 1, 5, 7, 9. 9 cannot be here because of the 8-9 pair in the row, so we have a guaranteed 9 in one of these two cells. Okay. This adds up to 20, and this adds up to 20. This is guaranteed to have a 9 here. So either this is 6 and 9, or it's 8 and 9 here. So that means if this is 6 and 9, that's 15. If this is 8 and 9, it's 17. Well, with 8 and 9 here, that means this is 20 minus 17, which is 3, and it would have to be 1 and 2 as unique digits. If this is 6 and 9, then this has to be 1 and 4 or 2 and 3 here. So this is guaranteed to be those digits there. This has to be blue 3 or 4. Red 3 or 4 has to be one of those two. Oh, this adds up to 16 here. Can we have 1 or 2 here? No. The answer is no, because this is at most 12, with 4 and 8 being a pair. And 12 plus 2 is at most 14, which is too small for the sum here. So this has to be 7 with 3 and 6 here. That means this is 7, no 7 here. This must be 3 and 6 as a pair. Let's remove 3 4s. So these have to be 6. Which means these are 3. This is 6, which eliminates 6 in the rest of, for the blue, 6, 8 pairs. So this must be 8, which means these are 4. Okay, this cannot be 3 anymore here. 6 eliminates 6 here, so this is 9 and 8. 8 eliminates 8 here, so it's 9 and 6. Well, that makes this 1, 2 as a pair to add up to 20. That eliminates 1 and 2 there. 7 eliminates 7 here, so this is 5. No 5 or 7 here. No 5 here. This cannot be 3 anymore here, so this is a 4, 5 pair, which adds up with 1 to add up to 10. So this is 1, which makes that 2, which makes that 1, which makes that 2. This is 8 and 9 as a pair here, which means this is 1 and 2 as a pair here. This can't be 2 because of 2 in the row. So this is 1, which makes that 2. That eliminates 1 in the rest of the row here. That's a 5, 7 pair in the central box, which eliminates 5 and 7 in the rest of the box. So this is 1 here, which eliminates 1 here, so that's 2. No 2 or 5 here. This 1 eliminates 1 here, so it's 7 and 1. That means this can't be 1 or 2. It's 5. 2, 5, and 3 add up to 10, so this is 3 there, which makes this not 3, 4, 5, it's 7. 7 eliminates 7 here, so it's 5 and 7. 5 eliminates 5 here, so it's 4 and 5. 8 eliminates 8 here, so it's 2 and 8. 2 eliminates 2 there. No 2 or 3 there. It's 1, 4 as a pair here, which eliminates 1, 4 in the rest of the column. Also, 6 eliminates 6 here, so it's 9 and 6. 9 eliminates 9 here, so it's 1 and 9. That means this can't be 1 or 4 or 3, so this is 2. This can't be 1, 2, or 4. It's 3. No more 2 or 5 here. 1 eliminates 1 from being in the rest of this box. This can't be 7 or 3 because of 7, 3 in the column, so this is 5. No 5 here, no 5 there. Adding up to 10, it's 2 plus 2 other digits. That means the other digits must add up to 8. 4 cannot add up to another digit with an 8, so this must be 1 and 7, which makes this 5 and 4. And we should just be able to do normal Sudoku. Okay. 1, we don't have any information. 2, in column 9, 2 cannot be here because of 2's in the boxes. 2 can't be here because of 2 in the row. So 2 has to be there. We have 8 2's. We know where the last 2 is. It's there. 3. We don't really have much information there. 4's. We don't really have much information there. 5. In this lower, in column 9, 5 cannot be here in the boxes because of, cannot be there because of 5 in the boxes. So this must be 5 there. In row 4, 5 can't be here because of 5 in the boxes. 5 can't be here because of 5 in the column, so 5 is there. That gives us 8 5's. We know where the last 5 has to be. It's there. 6's should all be there. Yep. 7's. We don't really have that much information on 7's. 8's, we have all the 8's. 9's, we have all the 9's. So then 1's. Oh, this adds up to 16 here. Can't be 1, 3, 6. That only adds up to 10. So this is 3, 6, 7, which makes that 1. Okay, there we go. So that with the differentiator there. That should help. We now have 8 1's. We know where the last one is. It's there. 3's. In row 7, 3 can't be here because of 3 in the box. That leaves that as a 3. We don't have any other differentiators here. 4. In row 8, 4 has to be there. In this left central box, 4 cannot be here or here, so 4 has to be there. In row 7, 4 has to be there, and that gives us 8 4, so the last 4 is there. Okay. We have all the 5's, all the 6's. 7. In row 4, 7 has to be there, which makes that 3, which makes that 7. That gives us 8 7, so the last 7 is there, which leaves that as a 3. And that's a solution. Yeah, fairly straightforward. Just some addition and, yeah, just basically some adding up of numbers. I totally forgot about the cages here, which is important, obviously, to have. But, I mean, the coloring was useful, too. We would have gotten that eventually anyways, so... But that's another way of sort of approaching these puzzles, is seeing if there are potential situations where a digit has to be a certain type of digit, right? So, anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.